Today we're going to take a look at the graphs of inverse trig functions. So here's our sine graph, and what you might notice about this is that this function is not one-to-one. If we draw a horizontal line, we'll pass through the function more than once. We'll actually pass through infinitely many times. So sine fails the horizontal line test, which means that it does not have an inverse. But if we restrict the domain, and let's say we only look from here to here, so it's negative pi over 2 to pi over 2, just this one single section here, notice that on that interval, sine is one-to-one. So if we're just looking at this piece here, we can draw horizontal lines and only pass through once. So if we restrict the domain of sine to be pi over 2 or negative pi over 2 to pi over 2, we can find an inverse. So what would that inverse look like? Well, you remember that the domain and the range interchange. So if we look at this point here, this is pi over 2, 1. Let's take this point. This is the origin, 0, 0. And this point is pi over 2, negative 1. Or that should be negative right here. Okay. So let's draw our inverse function based on those 3 points. So here we've got pi over 2, 1. Those will switch, so we should plot the point 1, pi over 2. Here we have the point negative pi over 2, negative 1. Those will switch, so we'll have the point negative 1, negative pi over 2. Right about there. And then the origin's nice, because if we switch 0, 0, we still end up with 0, 0. So this is what inverse sine looks like. It's just that one little piece. Its domain is negative 1 to 1, and the range is negative pi over 2 to pi over 2. So up top, this is sine. If we restrict the domain, we end up with a function that's 1 to 1, which means that we can draw an inverse function. And this is the graph of inverse sine. Sometimes you see this written instead as arc sine. These mean the same thing here, inverse sine and arc sine. All right, let's go take a look at cosine. Okay, here's cosine, and you can see that cosine is not one-to-one. Cosine fails the horizontal line test unless we restrict the domain. So if we just look at cosine between 0 and pi, so just this section right here, you see that cosine is one-to-one, will pass the horizontal line test, and will have an inverse on this interval. So here we're looking between 0 and pi. Okay, so let's do the same thing with the points. We've got the point 0, 1. Down here we've got pi negative 1. And then in the middle, that's pi over 2, 0. So to draw our inverse, we'll switch the x's and the y's. So instead of the point 0, 1, we're going to plot the point 1, 0. And instead of the point pi over 2, 0, we're going to plot the point 0, pi over 2. And then, instead of the point pi negative 1, we're plotting negative 1, pi. And here is our inverse cosine function. So it's just this one little piece. The domain is -1 to 1, and the range is 0 to pi, right? The range goes from 0 all the way up to pi. So this is inverse cos written like that, or we can call it arc cos. Okay, last one is tangent. Here we have our tangent graph. Again, tangent is not 1 to 1, so it doesn't have an inverse unless we restrict the domain. And we're going to restrict the domain so that we're just looking at this one section right here. So we're only looking between -pi/2 and pi/2, and we're not including the endpoints because we have asymptotes here. Asymptotes at -pi/2 and pi/2. So here, to draw the inverse, rather than thinking about switching the points, why don't we think about reflecting this over the line y equals x? So that diagonal line that bisects the first and third quadrant. So if we were to reflect this section here over that diagonal line, we'd end up with inverse tan. So what's going to happen here is that our asymptotes will now be horizontal, and those will be at pi/2 and -pi/2 on the y-axis. And that section will be reflected. It'll still go through the origin, but is going to look like that. So this is inverse tan or arctan. And the domain is all real numbers, and the range is between -pi/2 and pi/2. So here is our summary. I've got arcsecant in there, which we really are not going to concern ourselves with. So we're just going to look at the three main functions, arcsine, arccos, and arctan. And what you want to know is the domain and range of each of those. So here, arcsine and arccos, their domain is restricted to being between -1 and 1, just like the range of sine and cos is between -1 and 1. And arctan, the domain, is all real numbers. The range, very important for what's coming up, so make sure that you've memorized these. For arcsine, it's between -pi/2 and pi/2, including those endpoints. Tan is also between -pi/2 and pi/2, but we're not including the endpoints because we've got asymptotes there. And arccos will be between 0 and pi.